Hi all, let us see electric potential part 2. We're going to see potential difference between 2 points, which is change of V equals to V final minus V initial. Therefore, the potential difference between point A and point B, which is VAB, is given by VB minus VA. By attempting these A-level questions, we're going to apply the electric potential concept. A rectangle ABCD has length AB 4.0 meter and breadth AD 3.0 meter. Point charges Q1 is equal to 0.08 microcoulomb and Q2 negative 0.03 microcoulomb are placed at A and C respectively. Determine A, the electric potential at point B. This is the rectangle ABCD and we're going to find electric potential at point B. Point B is surrounded by point charge Q1 and Q2 and we're going to find electric potential from B to A and B to C. Given Q1 is positive 0.08 microcoulomb followed by Q2 is negative 0.03 microcoulomb. So VB, electric potential at point B, is K Q1 over RAB plus K Q2 over RBC. Positive sign or negative sign are dependent on this electric potential. So we have to consider positive sign and negative sign in the part of calculation. So we substitute all the possible values accordingly into this equation and finally we can get electric potential at point B is 90 volt. Simple like a bubble without giving you any trouble. For the section B, determine the electric potential at point D. So point is here. So we're going to use the same method to find the electric potential at point D. By using the same method, where electric potential at D is K Q1 over RAD plus K Q2 over RDC or CD. We're going to substitute all the possible values accordingly into this equation and we will get the electric potential at point D is about 172.5 volt. Simple like a bubble without giving you any trouble. And how about section C? Determine the potential difference between point B and D. So the electric potential difference between point B and D is about VD minus VB. We already got the electric potential for VD and VB from the previous questions or previous section, which is VD is 172.5 volt and VB is 90 volt. So we have to just substitute these values into this equation to get the potential difference between point B and D, which is equals to 82.5 volt. Piece of cake, you just need a cup of coffee at this moment. And the final part, section D, determine the work required in moving a point charge Q 0.5 microcoulomb from D to B. The work required in moving a point charge Q 0.5 microcoulomb from D to B is about electric potential D to B equals to work done D to B over positive test charge. This positive test charge Q is equals to 0.5 microcoulomb. B is your final and D is initial. We're going to substitute all the possible values into this equation and the work required is negative 4.125 times 10 to the power of negative 5 joule. Simple like a bubble without giving you any trouble. Thank you for watching this video. Thanks a lot and thank you to the Lord.